Greetings and welcome. Today we're going to talk about our last skill needed to solve right triangles. Now, you might think, I don't know, Mr. Waddy, I'm actually pretty good at solving right triangles. However, there's a situation you're not considering, perhaps. The right triangle in which we know two sides and a right angle, but don't know another angle. Before we get there, I first want to talk about how we might solve these following two equations, all right? Which I guess you could almost think of as like mathematical riddles. Solve for which 0 degrees is less than or equal to x is less than or less than 360, all right, is what I'm looking for. Because technically these equations could have infinitely many answers due to the coterminal nature of angles. So let's say I have the equation cosine x is equal to the square root of 3 over 2. So the riddle behind this that I'm trying to figure out is, all right, so here I know the ratio, but I'm not sure what the angle is. All right? So I'm trying to figure out for what values of cosine, for what angle, all right, would I take the cosine of and get the ratio of the square root of 3 over 2? So I'm asking kind of the question in reverse. Typically we've had, I give you the angle and you tell me the ratio. Now I'm giving you the ratio. I want you to give me the angle.
Why are you using cosine again?
This is just randomly like, this would be like what the question started as. Eventually I'll start relating it to triangles and whatnot. So this is what I'm solving, and I specifically want the values, your solutions, to be within that range, is what we're asking. Good question, good question. So let's see, what was I just going to ask? No, that's fine, it's fine. We're good. We are good. So cosine of what angle gives us this ratio? Aha, that was the first thing I was going to say. Now the first thing I realized is that this is positive, right? So for what quadrants is cosine positive? 1 and 3? 1 and 4, right? So I'm expecting that my angle is going to be somewhere between 0 and 90, right? Or from 270 to 360, right? So, and I could actually possibly have two answers because remember, there's, right, this angle and this angle have the same reference angle. So that would be possibly like two answers that would give me that, right? Something like that. So I know I'm looking in those two quadrants. Now, in this case, square root of 3 over 2, that's hopefully a pretty familiar ratio to us. Does anyone know when cosine gave us root 3 over 2? In fact, we could actually... Now, I could actually use my hand trick backwards. Remember, cosine is the square root of the number of fingers to the right, divided by 2. Right, so at 0 degrees, it's the square root of 4, which is 2 over 2, which is 1. At 30, it's the square root of 3 over... square root of 3 over 2, right? This would have been root 2 over 2. This would have been root 1 over 2, which is just a half. And root 0 over 2 is 0. So I just want to point out that we kind of could have guessed this answer, all right, where you could have said, well, x is equal to 30 degrees, right? But I think that's more specifically just my reference angle that I have, right? So I know that my reference angle of 30 degrees would work. So 30 degrees in that quadrant or that quadrant. So what are the actual angle measures for those two angles? So this angle is also 30 because it's in quadrant 1. So that's actually a solution. And then what would this angle be? 330, right? I could find the actual angle from this reference angle of 30 by subtracting 30 from the 360, right? And angle addition postulate kind of used in reverse would give me 330 degrees. All right, so we kind of could figure that out, all right? Not necessarily the most elegant way, but we figured it out. So let's see, similar question, same type of problem. What if I ask, when is sine x equal to negative root 2 over 2? All right, so I guess I could label this part A, part B of this question if I wanted. So when is sine For what angle would sine equal negative root 2 over 2? Let's first figure out what quadrant we're in. Narrow down our search, right? No need to search the whole planet far and wide, north, south, east, and west for the angle, right? Let's narrow it down. What quadrants is sine negative? 3 and 4, right? Okay. So when I find my angle using my hand trick or whatever, once I find the reference angle, I realize that I'd reference angle in both of those and then have to find my actual angle for both of those, right? So in this case, I'm actually expecting both of them to be greater than 180 and less than 360, all right? And if I did not have this restraint, then technically there would be infinitely many solutions to this problem, right? Where once I found my angles, I could just keep adding or subtracting 360s from it infinitely many times and then find all possible solutions, right? So, all right, so I know I'm in one of those quadrants. So let's see if we can figure out for what value of x do I just get the square root of 2 over 2. And I see some of you guys already were hand tricking it. So sine is the square root of fingers to the left, right? Square root of 0 is 0, over 2 is 0. Square root of 1 over 2 is 1/2. Square root of 2, ooh, wow. So what finger is that? 45-degree finger. So I guess maybe I'll call this x sub r or alpha for reference. I don't know, because this isn't actually my answer. But the reference angle is 45 degrees. All right, look at this. Oh, now it's a reference angle. Haha, that's funny. So I know that I'm 45 degrees in this quadrant and 45 degrees in this quadrant for my reference angles.
So there's always two possibilities?
If I've restricted it to those two quadrants, yeah. Yeah. So now the question is, if I've restricted it to the 4 original quadrants from 0 to 360, there would be 2 solutions. So now I'm looking for this angle and this angle. So x, what is the angle in the 3rd quadrant that has a 45-degree reference angle? So 180 plus 45, so that's, 225 degrees. I like it. And the one in the 3rd quadrant would be either 360 minus 45, or in this case also 270 plus 45, because I've kind of met the halfway point here. So what's that, 315 degrees? Right? So I've found both of my solutions, kind of logically I've figured it out. Now it turns out that there is a technique for finding the angle of a trig ratio when I know the ratio and not the angle. All right. Now think about the trig functions. All right. A little side note here. The trig functions. All right. If I'm thinking about domain and range or inputs and outputs, you input an angle and it outputs what? It gave us a ratio, is what the trig functions did, right? So if I said sine of 30 degrees, right, I gave it an angle, the trig function is equal to a ratio, right? Sine of 30 is 1/2. So I'm actually desiring a function that does the opposite of that. Do you guys remember what we called functions that undid each other back in the day? What's the concept of undoing in mathematics? Reciprocal is the undoing of multiplication. Subtraction is the undoing of addition. Right? Those are what kinds of operations? Do you remember? Actually, we even had it in matrices where we used the blank of a matrix. Close. We're getting there. We're warmer. Starts with an I, to, instead of dividing, because I didn't know how to divide, we used an inverse of a matrix to undo multiplication, right? So inverse functions undo each other is the idea, all right? So I would desire the inverse of the trig functions, and that's actually what they're called. They're called trigonometric inverses. All right, And with trigonometric inverses, I'm going to input a ratio, and it's going to output an angle, is the idea. Okay? And the way these trig inverses look, all right, so for this we had sine theta, right, cosine theta, tan theta, etc. In this case, the trig inverses, they actually have two potential looks. I'm personally fond of one notation style of them, but you should know both, where I'll have sine inverse of some ratio, and it's equal to an angle. Okay? So sine to the -1, we've seen the -1 used in inverse functions before, like previously in Math 3. If we had f of x, I said that the inverse function was f inverse of x, right? We've seen that to the -1 used in matrices. If I had matrix A times matrix A inverse, we knew that that was equal to the identity that Amber you just mentioned, right? So there was a relationship between inverse and identity. So that's what this means, sine inverse. And in fact, it even exists on your calculator, depending on what kind of calculator you have, I suppose. So notice right above the sine button is the sine to the -1, cosine -1, tan -1. So to access those, I use the secondary function of the button. So I'd hit second, right, sine inverse. And the problem is, I don't want to give this an angle. I need to give this a ratio. All right. So for instance, if I turn my calculator on and I want to calculate the sine inverse of something, so if I do sine inverse, all right, sine inverse, all right, you can see it there. If I give this a ratio, say like 1/2, when is sine equal to 1/2? It's cheating right there. It was hiding the whole time. Sine inverse of 1/2 should equal 30 degrees, and it does. Okay. Now, the thing with inverse functions on a calculator, you still need to sometimes be smarter than that. Okay. You might need to realize that maybe this is, 30 degrees is not the only answer to this question. You might also have to consider, that sine is positive 1/2 in the second quadrant, right? So technically 150 degrees is also an answer to this question. All right, so don't just accept this at face value. Think of this as kind of more like your reference angle that it's giving you, and that should help you out. But the idea is I input a ratio, and it gives me an angle. And that angle is in whatever mode you're in, so I'm in degree mode, so it's giving me the degree. All right? Now, I just want to point out, if I try to do sine inverse of 30, not 300, that's going to give me an error. It says, I don't know what 30 is. Sine inverse doesn't communicate that way, right? It doesn't accept a degree, all right? It's accepting only a ratio. And in fact, the inputs that it allows, I don't know if you guys remember this, but the outputs from sine were always between -1 and +1. Actually, I might even describe that as the range of sine. Was the set of all, I don't know, y such that -1 is less than y is less than 1, well, less than or equal, I guess. Right, the range for sine and cosine. Tangent was different. Tangent actually did go all the way from -infinity to +infinity. But for sine, that was the range, the outputs. So the inputs, the domain here, is actually going to equal the set of all x such that -1 is less than or equal to x is less than or equal to 1. All right, so I just want to point out that for inverse functions, their ranges and domains switch. Okay, so let's get down to how this is actually useful. If I flip back up here real quick, mathematically, if I wanted to solve this without just kind of logically thinking about it, the way to get x by itself, you could have actually done this, where I would have cosine inversed both sides. All right, and the cosine inverse of cosine of x, this undoes that, and it just gives me x. Okay, and then the cosine inverse of the square root of 3/2, I could either know from the hand trick or plugging it in the calculator that that's going to equal 30 degrees, and then I could figure out the 330 using my other skill sets. So what I want to point out about a trig ratio, the question that it asks is what angle gives me this ratio? All right. So if you see sine inverse of something, that's what it's asking. That's what it actually means. So let's see if we can actually get to a question. Let's say I want to find x in this case. All right. And we'll apply this to greater triangles and greater degrees on homework. I've only got time for one problem here now, sadly, but that's fine. Suppose this is 2, this is 6, and I'm looking for, let's say, this angle right here, this x degree angle. All right. Now, I'm going to use the same skill set that I've had before. 2 here is the opposite, 6 is the hypotenuse. So from the angle that I'm looking for as perspective, what trig ratio compares those things? That's sine. So I'm going to say sine of x degrees, or x, is equal to 2 over 6, right? Or 1/3. So to solve this equation, you could sine inverse both sides. Now, would I expect this to be a second quadrant angle in this case? No, this should only be an acute angle because this is now restricted to a triangle. So if I go to my calculator, I can hit second sine inverse, and I'm going to plug in 2/6, or better yet 1/3. I might even close the parentheses for good measure, and I'll get 19.47. So what that means is my angle is 19.47 degrees. So now we've just equipped you with the skill of being able to solve for an unknown angle if you know your sides.
So if you go into the calculator and you type sine inverse and then 2 over 6, it should give you the...
That would give you the same thing because your calculator would know. So that's the whole idea, folks. Thanks for watching. Tienen un día el más bien del mundo.